Hello everyone, welcome to Rashmi YouTube channel. In this video, I am going to cover the second PUC Maths syllabus. So now I'll start with the first chapter, that is relations and functions. Please watch the complete video for better understanding and don't forget to like, share and subscribe to my channel. So now let me start with the introduction part. So now I'll start with 1.1. So as we all know that we have already studied some of the part in the first PUC. So now I'll start with the first topic, that is relations. So what is relation? So in general we can call like brother sister relation or father son relations. So that is how this word the relation is derived from. So let me give an example, like the A is brother of B, or the A is sister of B, or A and B will study in the same school, or A scored more marks than B. So these are some of examples for the relation. So in this we will come to know that there is some connection between those two elements. So in your textbook you can see they have already given some of the examples, like A comma B belongs to A cross B and A is brother of B, and you can see here A is sister of B and the age of A is greater than B, and total marks obtained by A in the final examination is less than the total marks obtained by B in the final examination. So see, these are some of the examples, and how we can write it as like A is related to B. So that we can write it as A R B. So this represents A is related to B. So now I'll go with the next topic, that is type of relations. So that will be covered under 1.2. In these types of relations, so let me start one by one. So here in this section we would like to study like the different types of relations. We know that the relation like in set A, it is a subset of A cross B. Set A is the separate subset of A cross B, and the empty set will be also a subset of A cross B. Here we can see A is a universal set and this is a empty set. So I'll explain this with an example. Let's take an example. A is equal to 1, 2, 3, 4. So this is one set. And now I'll define a relation. R is equal to A comma B and A minus B is equal to 10. So now you just try to build a relation by using the set A. So let me take 1. If I take 1 comma 2 and define this relation, 1 minus 2 will be minus 1, which is not equal to 10. So now if you take any numbers from the set A, you can take 2 comma 1 or you can take 3 comma 4 or you can take 4 comma 3. But when you minus 3 comma 4 or 3 comma 4 comma 3 or 3 comma 1, so none of the values are equal to 10. So now what happens? The relation will become empty. So this we call it as empty relation. Now let me explain you the universal set. That is, let me take one more relation, that is R dash is equal to A comma B mod of A minus B should be greater than or equal to 0. Now again start defining the relation. R is equal to, you can take 1 comma 1 So when you take 1 comma 1, what happens? 1 minus 1 is equal to 0. So that is equal to or greater than 0. So you can define 1 comma 1, and you can take the next set as 1 comma 2. So 1 minus 2 will be minus 1, and mod of minus 1 will be plus 1, which is again greater than 0. You can take 2 comma 1. This is again 2 minus 1 will be plus 1, which is again greater than 0. You can again take 3 comma 4. 3 minus 4 will be minus 1. Mod of minus 1 will be plus 1, again greater than 0. And you can take 4 comma 3. Again 4 minus 3 will be plus 1, again greater than 0. So like this you can define the relation. So in this relation you can see all the numbers here, 1 2 3 4. So this will become a universal set, because in the relation we can define all the numbers. So now you can see this will be the definition 1, and this will be definition 2. So that is universal set and empty set. Now let's take an example. Let A be the set of students of boys in a school. So these are the set of students of boys in a school, and show that the relation R is given by R is equal to A comma B, and A is sister of B. It is an empty relation. So how we can show that? As they have already mentioned that A is the set of boys school, so that means there are no girls in the school, so A cannot be a sister of B. So now what happens? R will become empty, so this will become a empty relation. Now I'll take the next example, that is R dash is equal to A comma B, and difference between the heights of A and B should be less than 3 meter. See, you can take any two boys. So the height difference between any two boys obviously will be less than 3. So now what happens in the relation? All the boys will come. So this we call it as a universal set. Okay. So now just one note point here. Let's take an example. Let's take a class 11. In class 11, we have seen two ways of representing a relation. So namely, that is raster method and set builder method. Okay. So one is raster method and next will be set builder method. Okay. So now let me take one example here. Relation. So set R is equal to 1 2 3 4, and the relation is defined as A comma B, where B should be equal to A plus 1. This is also expressed as A is related to B, as I have already told this before. So now I'll go with the next definition, that is definition 3. So in this definition, so I'm going to explain you. There are three things. One is reflexive, second one is symmetric, and third one is transitive. What is reflexive? A comma A belongs to R and A should belongs to set A. So let me show you this with an example. Let's say for example in R we have 1, 2, 3, 4. So if the relation is like 1 comma 1, 2 comma 2, 3 comma 3 and 4 comma 4. So this type of relation we call it as a reflexive relation. Next, symmetric. If A1 comma A2 belongs to R and A2 comma A1 should belongs to R, that is symmetric relation. So in case if 1 comma 2 belongs to R and 2 comma 1 belongs to R, so this we call it as symmetric relation. Next, A1 comma A2 belongs to R and A2 comma A3 belongs to R and A1 comma A3 also will belongs to R. So this we call it as transitive relation. So for this we can take an example. If 1 comma 2 belongs to R and 2 comma 3 belongs to R, then 1 comma 3 also should belongs to R. So this type of relation we call it as transitive relation. So now I'll go with the definition 4. So in this definition 4, if a relation, if R is all three, that is reflexive plus symmetric plus transitive. If the set includes all three relations, then we call this as a equivalence relation. So let me take an example. Let T will be the set of all the triangles. So let me take T will be the set of all the congruent triangles. So what is congruent? Congruent means having equal sides and equal angles. Let's say for example, if the triangle 1 is having 6 meter, 6 meter and 6 meter and having 60 degree, 60 degree and 60 degree, and even the triangle 2 also will be having the same sides and same angles, and even the triangle 3 will be having same sides and same angles. So these are the set of congruent triangles. So I'm going to take the set as the set of congruent triangles. So now we have to define whether it is reflexive, symmetric or transitive. So here I am going to take 1, 2, 3, or you can take 4 and 5. So in this all these 5 triangles, you can see all the sides are equal and all the angles are equal because these are the congruent triangles. So now we will define the relation. R is equal to, can I write 1 comma 1? Yes, I can. Why? Because the triangle 1 and the triangle 1, we can define this. Both triangles are having equal sides and equal angles. So I can write 2 comma 2 also. I can write 3 comma 3 also. I can write 4 comma 4 also. And even I can write 5 comma 5 also, and so on. Next, so this we call it as reflexive. Now I will define the next relation. I can write 1 comma 2 because triangle 1 is having equal sides and equal angles, which is same as triangle 2. So I can write 2 comma 1 also. Why? Because both are same triangles. So this we can call it as a symmetric. Now when I define the next relation 1 comma 2, I can write 2 comma 3 because again second triangle is same as the third triangle, and now I can write 1 comma 3. So here also you can see the first triangle having same sides and angles when compared to third triangle, so both are equal. So this we call it as transitive. So I hope you are understanding. Let me take one more example here. So let L be the set of all the lines in a plane. See, now I'll draw some lines in this plane. So these are all parallel lines and these are some perpendicular lines. Okay, so let L be the set of all the lines. In this L set, I'll be having all the lines. And now I'll define relation R as L1 comma L2, and L1 should be perpendicular to L2. So now I have to identify whether it is reflexive, symmetric or transitive. So let me take this one as L1 and this one I'll take it as L2. This one again I'll take it as L3 and this one again I'll take this as L4. So now how I can define the relation? R is equal to L1 should be parallel to L2. So can I write L1 comma L1? No. Why? Because L1 itself cannot be perpendicular to the L1. So this is not reflexive. So it is not reflexive. Now can I write L1 comma L2 and L2 comma L1? This is L1. Sorry, this is L1 and this one is L2. Here the L1 is perpendicular to L2. So I can write L1 comma L2. Now can I write L2 comma N1? Yes. So this is L2 and L1. Even here the L2 is perpendicular to L1. Yes. So now this will be symmetric. Now next. So I can write L1 comma L2 and I'll write L2 comma L3. Now L1 is perpendicular to L2 and L2 is perpendicular to L3 . Okay, so this is L3. So now L2 is perpendicular to L3. So I can write this now. So what is transitive? It should be L1 and L3. Now check. This is L1 and this is L3. So is L1 is perpendicular to L3? No. So now this is not possible. So this is not transitive. So now here what happens? L1 is parallel to L3. So the relation is not reflexive and not transitive, but it is symmetric. So let me explain you one more example. Now I am directly take one relation. R is equal to 1 comma 1, 2 comma 2 and 3 comma 3. And I'll write 1 comma 2 and 2 comma 3. So now I have to check whether it is reflexive, symmetric or transitive. So before this I'll give R is equal to 1 comma 2 comma 3. Now you can see here in R I have three numbers, that is 1 2 3, and in relation I have 1 comma 1 and 2 comma 2 and 3 comma 3. So this is reflexive. So now we can conclude this as reflexive and check. In this I have 1 comma 2 and check whether we have 2 comma 1 in this. No, there is no 2 comma 1 in the relation. So what happens? This is not symmetric. Now check the third case, that is 2 comma 3 is there, 1 comma 2 is there, and 2 comma 3 is there, but 1 comma 3 is not there. So this will be not transitive. So now I'll go with the next example, that is example number 5. So in this there is one relation R is equal to A comma B 2 divides A minus B. And Z is the set of all the integers. So now when defining the relation, you can see R is equal to A comma B and 2 divides A minus B. So let's take an example. So now integer you can define it as, so on you can write it as minus 5, minus 4, minus 3, minus 2, 0, and plus 1, plus 2, plus 3, and so on. So this will be a set of integers. Okay, so now I have to define the relation R is equal to, can I write 1 comma 1? Yes, I can, because sorry. So now I have to match to this relation 2 divides A minus B. So I can write 2 comma 4. So when I do 2 minus 4, it will be minus 2. So when I divide it by 2, it will be minus 1. So this belongs to the set Z. So I can define the relation as 2 comma 4, also 4 comma 2. You can also define it as minus 2 comma minus 4 and minus 4 comma minus 2. So on. We will get a set of relations here. And I can define one more set of relations, that is 1 comma 3 or 3 comma 1. So when I do 3 minus 1, it will be 2, and 2 by 2 will be 1. I can define it as 9 comma 1, also 1 comma 9. So from all these set of relations, you can see that in the first relation I can take only the even numbers, and in the second relations I can take only the odd integers. So when I take one even and one odd integer, I'll take 1 and 4. So here the 4 is even and 1 is odd. So when I do 1 minus 4, this will become a odd integer, and you cannot divide this by 2. So you cannot take one odd integer and one even integer in this relation. You can take odd integers or only the even integers. So then you can define a relation. And also you can see this relation will be reflexive. Why? Because you can define relation as minus 1 comma minus 1, minus 2 comma minus 2, minus 3 comma minus 3, because all these numbers will be divided by 2. And also, so this we call it as reflexive. Now you can also see here 2 comma 1 is there, 2 comma 4 is there, and 4 comma 2 is there, minus 2 comma minus 4 is there, minus 4 comma minus 2 is there. So this will be symmetric, and also it will be transitive. Why? Because when I take 2 comma 4 and I can take 4 comma 6, I can also take 2 comma 6. So when I do 6 minus 2, it will be 4. So divided by 2 will be 2. So this is transitive. So when it will be all three, reflexive, symmetric and transitive, so this Z set will become equivalence relation. So from the previous example, you can also see that in Z we will get two sets, that is even integers and odd integers. In even integers you can see 2, 4, 6, 8 and so on. In odd you can see 1, 3, 5, 9, etc. So here none of the elements from set E belongs to set O, and none of the elements from set O belongs to set E. So here Z will become E union O. And when you do E intersection O, this will become an empty set. So now I'll go with the next example, that is example 6. So let me define R as a comma B, and here A and B, this can be either even or odd. So you cannot take one even number and one odd number. You can take either even number or the odd number. So I'll define set A as 1, 2, 3, 4, 5, 6, 7. So now I'll just check whether it is symmetric, reflexive or transitive. So when I define the relation R, you can write 1, 1. Yes, you can, because 1 is an odd number. And you can write 2, 2, and both are even number here. You can write 3, 3 because both are odd number here. So this will continue. So now what happens? This will become reflexive. Now I'll define the next relation. I can write 2, 4, and also I can write 4, 2. But I cannot write 1, 4. Why? Because I cannot write one odd number and one even number. The relation will be either A and B both should be even or both should be odd. So now I can write only even numbers or odd numbers. I can write 1, 3. I can write 3, 1. So this represents it is symmetric. Now the next relation. So I can write 2, 4. I can also write 4, 6. Both are even. I can also write 6, 8. Both are even. So okay. I can also write 2, 6. So here 2, 4 is there. 4, 6 is there. And also 2, 6 is there. So this will become a transitive. You can also write this with the odd number. I can write 1, 3. I can write 3, 5. I can write 1, 5. Because here all are odd numbers. So this will be a transitive. So but in this example also the same thing. We will be having two sets, that is one is even numbers and one more will be odd numbers. So none of the elements from E belongs to O and none of the elements from O belongs to E. So this whole relation will become a equivalence relation. So this is about the introduction part about the relations. So in the next class we will go with the exercise 1.1. So in case if you have any doubts, please comment in the comment box. So I will try to solve all your queries. And thank you for watching. Please don't forget to subscribe my channel.